Hello everyone, I am Dr. Karthika from Department of Biomedical Engineering, SNS College of Technology, Coimbatore. And in this video, we are going to discuss about voltage, current, power and energy in DC circuits. First of all, what do you mean by charge? Actually, when defining electrical property of atomic particles, the electrons are negatively charged and protons are positively charged. The symbol is Q. Here, uppercase is used to denote steady state or constant value, and lowercase is used to denote an instantaneous value or time varying quantity. C. Then what is current? A flow of charge through a cross-sectional area as a function of time or time rate of change of charge. Here the symbol is I. C. Charge and current. A current of 1 ampere which is equal to 1 coulomb of charge flowing in 1 second. So I equal to Q by T, Q equal to IT. Here I equal to current in amperes and Q is charge in coulombs and T is time in seconds. Okay, what is this AC DC? Type of current we have AC as well as DC. Actually, DC is the acronym for direct current, AC for alternating current. DC, the current remains constant with time. Here uppercase variables are used to calculate DC values and here lowercase variables are used to calculate AC values. Here AC current varies sinusoidally with time and the average value of the current over one period of sinusoid is 0. Remember that. And we also have other time varying currents, but we don't have any specific acronym for that. We have only AC and DC. See, what do you mean by voltage? Voltage is a potential difference, an electromotive force EMF that causes charge to move. So V is equal to dW by dQ. And what is power? The change in energy as a function of time is power, which is measured in watts. Here power is equal to energy dissipated by time. P equal to E by T. Value of E is VIT by T. TT get cancelled. P equal to VI. From Ohm's law, V equal to IR. So P equal to IR into I. So P equal to I square R in terms of current. In terms of voltage, I equal to V by R. So P equal to VV by R. The value of P finally is P equal to V square by R. Actually, the formula is P equal to VI. In terms of current, we can rewrite P as I square R. And in terms of voltage, it is represented as P equal to V square by R. Okay, what do you mean by energy? We know that energy is the capacity to do a work. See, here the electrical energy is E equal to PT, value of P equal to E by T. Here E is energy in joules, P is power in watts and T is time in seconds. See here positive versus negative power. Power consumed or dissipated by a component is positive power. P equal to plus 1 watt. See, power consumed or dissipated is positive. See the example. And power generated by a component is negative power. P equal to minus 1 watt. Power consumed or dissipated is plus, power generated is minus. Remember that. And passive sign conversion, in this convention we have power generation and dissipation. Power is voltage multiplied with current. Power is absorbed if the power is positive. Voltage and current are consistent with the passive sign convention. Power is generated if the power is negative. Voltage and current not consistent with the passive sign convention. See, the first one 6 watt absorbed and 6 watt generated. Absorbed is positive and generated is negative. See, conservation of energy. Here summation P is equal to 0. It must be 0 because all power instantaneously consumed by components, it must be instantly generated by other components within the circuit. So summation P is equal to 0. See the example. See here, there are four electrical components in the circuit shown to the right. Here, component 1 is generating 2 watts of power and supplying this power to the circuit. Component 2 and 3 are consuming power. Component 2 is dissipating 3 watts of power, while component 3 is dissipating 5 watts of power. Here component 4, it must be generating 6 watts of power in order to maintain the conservation of energy. So our formula becomes summation P, which is equal to P component 1 plus 2 plus 3 plus 4, which must be 0. So finally we'll get minus 2 watt plus 3 watt plus 5 watt, which is equal to minus 6 watt. So component 4, it must be generating 6 watts of power in order to maintain the conservation of energy formula. The main thing is the conservation of energy must be equal to 0 throughout the circuit. See, here the relationship between charge, current, voltage, power and energy was presented here, and passive sign convention will also be used in this course. And conservation of energy means that a circuit must contain elements that supply all the power that is dissipated by the remaining elements in it. See, I have included some simple problems for your reference. The first one is voltage calculation by using Ohm's law. A 15 ohm resistor has a 3 amps current flowing through it. Find the voltage across the resistor. Here the formula is V equal to IR. We can multiply 3 amps with 15 ohms. We will get V equal to 45 volt. See the second one, current calculation by using Ohm's law. A 20 volt battery is connected to a resistor and the current flowing through it is 5 amps. Find the resistance of the circuit. By using Ohm's law, we can find R equal to V by I. So the R value becomes 4 ohms. Third one is power calculation. The formula is P equal to VI. Here the given voltage is 6 volt and the current is 2 amps. So the power value is 12 watts. And energy consumption E equal to P multiplied with T. The given P is 60 watt and the T is 8 hour. And energy for 10 days we have to calculate. So E total, which is equal to 0.48 kilowatt hour multiplied with 10. So finally we'll get the energy total, which is equal to 4.8 kilowatt hour. See. See the electrical power and resistance. Here P equal to VI, I equal to P by V, and the value of I equal to minus 0.454 amps, and R is V square by P. The value is I equal to 0.454 amps and resistance is 484 ohms. Thank you.